Algebra 2, letter problems, 112B. Looks like I'm missing the 1 on my 112. Okay, so this one it says find the exact value of cosine 11 pi over 12. So we want to use, well, actually, first thing you want to do is look at the unit circle and see if you can find 11 pi over 12. You're not going to. Well, none of these are in twelfths. So that's kind of a problem right there. So what I did is I took my unit circle and I started making some things that are twelfths. You know, I just converted pi over 6. If I multiply the top and bottom by 2, that's 2 pi over 12. Turns out that's 3 pi over 12. You know, because multiply the top and bottom by 3. So I'm trying to get a 12 in the denominators of all these fractions. So remember, I was looking for 11 pi over 12. So this would be 8 pi over 12. This would be 9 pi over 12. This would be 10 pi over 12. So am I going to make it? Is it going to? No, because this is pi. So this is 12 pi over 12. So there's no 11 pi over 12 on my unit circle. So I know, that's what makes me know that I have to probably use the sum and difference. So the one that I chose to use was, where is it? Well, I found out that now that I have them all in 12ths, that really helped me, because now I can figure out what plus what equals 11, right? So I got 3 plus 8 is 11. So I want to use my pi over 4 and my 2 pi over 3. And so we're being asked about cosine, so I look on here and I find my cosine formula. My sum formula for cosine. So so this is where you can find it. It's also in your book. I just wrote it down. I already rewrote it right here. So what I've done so far is this is the original problem. I decided I was going to break it down into, I had to do a bunch of fraction math, and I found out 8 pi over 12 plus 3 pi over 12 is the most obvious, or the simplest way to do this. So now 8 pi over 12, I just know from looking right here, 8 pi over 12 is the same thing as 2 pi over 3. Okay, and 3 pi over 12 is the same thing as pi over 4. So I kind of labeled them right here. Okay, so that's what I'm going to use for A and B. So then I plugged them in. Plugged them into the formula. So then now I'm just going to go, I think I can use this unit circle. Find cosine of 2 pi over 3. Should be on here, 2 pi over 3. There it is. So what's the cosine of it? Well, cosine is the first ordered pair. It's negative half. I like to make the empty spots so I don't get confused. Cosine of pi over 4, well, that's root 2 over 2. What's the sine of 2 pi over 3? Sine of 2 pi over 3. So 2 pi over 3 is right here, and sine is root 3 over 2. And then sine of pi over 4 is root 2 over 2. Okay, so I think I'm getting close to being done here. So multiply these together. That's negative root 2 over, what's 2 times 2? 4. And then this is root 3 times root 2, that's root 6 over 4. Those aren't, the radicands are different, so I just have to kind of leave it as negative. Something like that. Let's see how your book does it. This is letter B. They just left it just like that. So there's your answer. Okay. I'm going to try, I got enough time, I think, to do letter C. So letter C. Letter C wants evaluate cosine A plus B. So this one's tricky. If A is root 24 over 25, or sorry, 24 over 25, and that says that A is between negative 90 and positive 90, that means that A is in one of these two quadrants, because that's positive 90, that's negative 90. Okay, and tangent of B is negative 1, and that's also in these two quadrants. So the best way to do this is probably to use some triangles rather than using the unit circle. Okay, so sine A can only be, this is kind of like a unit circle right here that I drew. All students take calculus. So this is, I'm only looking at these two quadrants because it says it has to be in between positive and negative 90. That's y and that's x. Okay, I'm only looking in these two. Where can I have sine equaling a positive number of these two quadrants? Well, only here. Sine is the SO of SOHCAHTOA. So, and it said it was 24 over 25, so I drew my triangle and I put opposite was 24 and hypotenuse was 25. Now I'm probably going to end up needing this, and I can use Pythagorean theorem for that. I can go 24 squared plus b squared equals 25 squared. 25 squared is 625, but I don't know what 24 squared is. Probably do 24 times 24. No, I didn't know that. 576. Okay, subtract 576. 625 minus 520. Wow. 625. I got 49. So this B7. So this little side right here on this triangle, that's 7. Okay, so how does that help me? Because I have to find the cosine of A, and I didn't write down what A was. A was 24 over 20. Sine of A was 24 over 25. So the cosine, this is A right here. The cosine of A, cosine is adjacent over hypotenuse. So what's adjacent? It's this one. So it's going to be 7 over 25. Now B, angle B is right here. And I already wrote in that it was 45 because they told me that tangent of angle B was negative 1. And I know that the only time that tangent is going to be a 1 or a negative 1 is when sine and cosine are the same thing. You know what I mean? Like root 2 over 2. Because tangent is sine over cosine. So root 2 over 2 over itself, that's going to make negative 1. So that's how I knew it was. That's actually negative 45 degrees right there. So that's how I knew that was 45 degree. And then I know my triangle, my 45, 45, 90 has 1, 1, root 2. So what was I trying to find? Cosine of B. Well, cosine is adjacent over hypotenuse. Adjacent is going to be 1, and hypotenuse is root 2. So 1 over root 2. Okay, and then sine of B. That's B. So sine is opposite over hypotenuse, so it's going to be 1 over root 2. Okay, so if I work this out, I'm going to have to find more room to work that out. These two fractions multiplied together is 7 times 1 is 7, and 25 times root 2 is 25 root 2. And then this one's going to be 24 times 1 is 24. And 25 times root 2 is 25 root 2. We got a common denominator, 25 root 2. 7 minus 24. That gives me negative 17. And so I can't leave it like that because I have a root in my denominator. So multiply the top and bottom by root 2. That'll give me negative 17 root 2. This root 2 and this root 2 makes 2, and 2 times 25 is 50. So this is what I got. Let me check it. 31. Oh, they got 31 root 2 over. Oh, okay, so I messed up right there. That would have been 31. That's, here, let me write it right. 31 root 2 over 50.